You know what honestly frustrates me? Most guides on how to learn faster are completely missing the point. They throw a bunch of tips at you, use flashcards, study in chunks, but they totally ignore the engine that's actually doing the work, your brain. It's like they're teaching you how to pedal a bike harder, but they're not showing you that there's a gear shift that can make everything effortless. What if I told you that the secret to dramatically slashing your learning curve isn't about hacks, but about a physical change that happens inside your head? It's about moving a skill from your conscious, slow, and clunky prefrontal cortex to your unconscious, fast, and automatic basal ganglia. This is the biological process for making any skill feel like second nature. So in this video, I'm not giving you more surface-level tips. I'm handing you the 3-step neuroscience method to intentionally trigger that shift so you can turn conscious struggle into unconscious skill. To understand how to learn faster, you first need to get that your brain has two completely different systems for handling skills. The best way to think about it is like learning to drive a stick shift. At first, everything is manual. This is your prefrontal cortex, the part of your brain right behind your forehead. It's your center for conscious thought and working memory. When you're first learning anything, a new language, a bit of code, how to drive that car, your prefrontal cortex is in full command. You are painfully aware of every single tiny action. Your hands are glued to the wheel. Your brain is just screaming, okay, clutch in, shift to second, ease off the clutch, add gas. Not too much. It's slow, it's awkward, and it takes up 100% of your attention. You can't even think about holding a conversation or listening to the radio. This is the cognitive stage of learning, and it's defined by intense, focused effort. Now, picture an experienced driver. They're zipping through traffic, sipping a coffee, and having a deep conversation, all at the same time. How? Because the skill has moved over to their automatic system. This is your basal ganglia, a group of structures deep in the center of your brain. The basal ganglia are responsible for habits and well-worn patterns, for movements that are so practiced they've become automatic. The skill isn't a conscious calculation anymore. It's a deeply embedded program that just runs with incredible speed and efficiency. This is the autonomous stage of learning. The problem is, most of us stay stuck in manual for way too long. We practice in a way that keeps the prefrontal cortex constantly overwhelmed, never giving the skill a chance to get handed off and locked into the fast, automatic pathways of the basal ganglia. But what if you could manage that handoff on purpose? What if you could build a neural superhighway from manual to automatic? Well, you can, and it's a 3-step process. Neuroscience has given us a peek into the exact mechanisms that drive neuroplasticity, the brain's physical ability to change and rewire itself based on what we do. By using these mechanisms, we can create a deliberate practice system that speeds up the transfer from conscious effort to unconscious mastery. Here is the 3-step method to do it. First things first, stop trying to learn the whole thing at once. You have to break the skill down into its smallest, most fundamental pieces and practice those pieces one by one. Don't practice your entire tennis serve. For 10 minutes, practice only the ball toss. Don't try to write a whole app. Master one single function. Don't try to hold a full conversation in Spanish. Drill the conjugation of one high-frequency verb over and over. The science here is all about managing cognitive load. Your prefrontal cortex has a very limited bandwidth, kind of like the RAM on your computer. When you try to practice a complex skill all at once, you're asking it to juggle dozens of things simultaneously. It gets overwhelmed, your performance stinks, and the neural pathway it builds is messy. By breaking the skill down, you isolate one tiny component, which dramatically reduces that cognitive load. Now your prefrontal cortex can dedicate all of its resources to executing that one micro skill perfectly. It can build a clean, strong, and efficient neural connection for that specific action. You're laying one perfect brick, instead of trying to build a whole messy wall at once. So your first action is this. Take the skill you want to learn and smash it into the smallest possible pieces. Ask yourself, what's the atomic unit of this skill? For a guitarist, it might not even be a chord, but the movement of a single finger from one fret to another. For a public speaker, it might not be a whole story, but landing a single, impactful pause. Isolate that one thing, and for your practice session, do only that. This is where most people go wrong, and it's one of the most critical parts of learning fast. The goal is not to repeat that one micro skill the exact same way 1,000 times. The goal is to practice it with slight variations. This feels totally wrong, I know. We've all been told that repetition is the mother of skill. And while repetition is important for memory, mindless repetition is a terribly slow path to mastery. Studies show that practicing a slightly modified version of a task helps you learn much faster and more deeply than just hammering the exact same thing over and over. Here's the neuroscience. When you repeat the same exact motion, your brain quickly goes on autopilot. Your prefrontal cortex checks out. You're not really learning. You're just going through the motions. But when you introduce slight variations, practicing a little faster, then a little slower, from a slightly different angle, with more or less force, you force your prefrontal cortex to stay engaged and solve the problem anew each time. Every time you make a small tweak, your brain has to recall the existing skill, adapt it to the new condition, and then resave it. This process builds a far more robust and flexible neural pathway. You're not just building one road. You're building a whole adaptable network of side streets around that main highway. So your action here is to take that isolated skill from step 1 and introduce some controlled chaos. If you're practicing a chord change, do it 5 times fast, then 5 times slow. Do it with your eyes closed. If you're practicing a line of code, try writing a slightly different variation of that function. This yanks your brain out of lazy habit mode and into a state of active, flexible learning. The first 2 steps build the road. This third step paves it, strengthens it, and makes it permanent. You absolutely must practice with intense focus and an immediate, specific feedback loop. Just doing the reps isn't enough. You have to know instantly whether the rep was correct or incorrect, and why. This is the core of what researchers call deliberate practice. The neuroscience is about error correction and dopamine. When you try something and fail, your brain registers an error signal. That signal is critical for change. It tells your nervous system, that didn't work. Adjust. When you attempt it again and get a little closer to succeeding, your brain releases a bit of dopamine. That dopamine acts as a signal that says, yes, that's the right direction. Do more of that and strengthen that connection. Without an immediate feedback loop, you are flying blind. You could be practicing your mistakes, reinforcing bad habits, and paving the wrong neural highway. The shorter the delay between your action and the feedback, the faster your brain can make the right adjustments. This is also where another powerful technique, retrieval practice, comes in. Constantly testing yourself is one of the best forms of feedback. Your action for this final step is to find a way to see your mistakes in real time. Record yourself on your phone and watch it back. Use an app that gives you an instant score. Work with a coach who can say, stop, your wrist was angled wrong on that last one. Vague feedback like good job is useless. You need specific, actionable information tied directly to the micro skill you're practicing. So let's recap it. The 3-step neuroscience method to shift any skill from your slow, conscious brain to your fast, automatic brain is this. 1. Deconstruct and isolate. Break the skill into its smallest parts to manage cognitive load. 2. Practice with variability. Introduce slight changes to keep your brain engaged and build flexible, robust pathways. 3. Create a focused feedback loop. Get immediate, specific information on your performance so your brain can effectively correct errors and reinforce what works. This framework isn't just another set of study hacks. This is the user's manual for your brain's learning hardware. It's about shifting your entire mindset from just putting in the hours to practicing with surgical precision. It's about using the fundamental rules of neuroplasticity to take direct control over how you build skill. This is how you turn conscious struggle into unconscious mastery. You don't just learn the skill, you install it. If this video changed the way you think about learning, hit that subscribe button for more neuroscience-backed strategies. And now I've got a question for you. What is the #1 skill you are going to apply this 3-step method to first? Let me know in the comments below. I read every single one. Now go and start building a better brain.